Take 5,731. Hello everyone and welcome to Smart Home Dumb User, where we make nerdy things cool and cool things, well, less cool, I suppose. Anyway, in this video, we're going to install Home Assistant in Docker on a Raspberry Pi, officially called the Home Assistant Container. The reason I'm choosing to install Home Assistant Container as opposed to any of the other options that are available is really just a personal preference. Onward. The basic outline is we set up our Raspberry Pi, set up our external drive, install Docker and Docker Compose, and finally install Home Assistant. To get started, of course, we need a Raspberry Pi and the appropriate power cord, a micro SD card at least 8 gigabytes in size, although I'd recommend a minimum of 16 gigabytes to give us a little more room to grow, a USB to SATA adapter, and a SATA solid state drive. Now, if you don't already have these components, I'll include affiliate links in the video description below to the exact ones being shown here. Buying from these links doesn't cost anything extra, and it really helps support the channel. The reason we'll be installing Home Assistant on here is that the micro SD card where the operating system is installed has a limited amount of writes that it can sustain in its lifetime. So we need to minimize the number of writes to it. Other uses of the Raspberry Pi that aren't as write intensive may likely never reach this limit, but since Home Assistant is writing pretty much every change that we make to our smart home, as well as sensor history and state history, it can reach this write limit fairly quickly. And yes, SSDs also have this limit, but that number is far greater than a micro SD card. So to get started, we need to get an image installed and configured. These steps can change somewhat frequently with software and hardware updates, so rather than including them in this video, these steps, as well as the companion article for this video, are detailed in separate articles on smarthomedumbUser.com. And once you've completed those tutorials, plug the SSD into the adapter cable, then plug the adapter into an available port on the Raspberry Pi. If you're using a Raspberry Pi 4, use the blue USB 3 ports to get the maximum bandwidth our Pi offers. And with that, step 1 is complete. Now, I want to give you a heads up that the next part of this setup might seem a little intimidating and tedious. If you've never done them before, I strongly encourage you to go slow, be patient, take your time, mess things up, start over, mess things up again, start over again, but remember to be persistent and work through any problems you might have. It might be a bit frustrating to go through all of the commands only to mess up one line slightly and want to start over. But when you get it all right, it feels exceptionally good, especially good. All right, time to get nerdy. Next, we need to access the shell of our Raspberry Pi. We're going to do this through a remote management protocol called Secured Shell, or SSH. If you're
Loser!
If you're on a Linux or Mac system, there's a native SSH client already installed. On Windows, however, you'll need to install an SSH client. I, and let's just say millions of others, have used a utility called PuTTY for years, and it's probably the most popular SSH client for Windows. I'll also include a link to it in the video description below. So after we connect via SSH, we need to make sure our operating system has detected that our drive is plugged in. To do this, we issue the command sudo fdisk-l. The sudo command is more like a directive. It stands for superuser2, and its purpose is to run a specific command with superuser or root privileges. This is similar to the user account control or UAC dialog in Windows. That's the annoying little pop-up that asks whether you want to allow an application to make changes to your device. With sudo, we're implying that we want the command that follows it to run with root privileges. All right, we're done here. Back to the video. Sudo fdisk-l. This gives us a list of the drives that the Linux operating system has detected. Probably at or near the bottom, you should see your SSD listed. On my Pi, it's seen as /dev/sda or just /dev/sda. Your device name might be a little different, but its name should follow the format of /dev/device name. Since this is the only device plugged into our Pi, we can be 100% certain that we've identified the correct drive. You need to be aware that the Linux operating system is case sensitive. That means that this command and this command are entirely different things. So give close attention to the cases in which the commands and the command options are presented. Next, we're going to create and write a primary partition, again by using the fdisk command. Only this time, we're going to add the drive where we want to create our partition at the end of the command. So for me, that would be fdisk space /dev/fda, enter. Next, press N to begin creating a new partition. To make things as simple as possible, we'll only use the default options. To do that, simply press Enter through each of the options until you're back at the screen where we started. Once that's complete, press W to write the partition table and exit the fdisk program. The final thing we need to do in order to use our external drive is format it. To do this, use the command sudo makefs or mkfs.ext4 space /dev/sda and our partition number. For me, this means SDA1, but might be different for you as we previously discussed. And just as with our fdisk command, we're going to accept the defaults as they're good enough. Did we make it this far? Good. Let's keep going. We're about halfway done with step 2 and halfway to Home Assistant. All that's left is to make our drive a part of the folder structure of our operating system. To do this, we need to create a directory where our drive is going to reside. This is somewhat similar to assigning a drive letter in Windows, but in Linux we use what's called a mount point. Now, where you mount the drive is totally up to you, but for the sake of good system management, we are going to put it at /mnt/ssd, or as said by humans, /mount/ssd. So to create that directory, we use the mkdir or makedir command followed by the name of the directory we want to create. So sudo space makedir space /mnt/ssd, enter. Then to mount our drive here, we issue the command sudo space mount space /dev/sda1 space /mnt/ssd, enter. This command won't normally produce any output. However, if there's any errors on the screen, make sure you address those before continuing. To make sure the mount command was successful, we use a command called df, which tells us what disks are mounted and the locations that they are mounted to. As we can see here, our dev/sda1 partition is appropriately mounted at /mnt/ssd. At this point, our drive is mounted and available to use, but if we restart the Raspberry Pi for any reason, we would have to reissue that mount command again, every single time. So to make the mounting persistent, we need to edit a file, but we need some information first. We need to know the partition's universally unique ID, or UUID. We can find this by running the command sudo space blkid, or block ID. Don't let all of the numbers and characters on the screen here scare you away, as we're really only interested in the part beside our drive name that says part UUID equals and then a series of seemingly random alphanumeric characters. For now, just copy all of the characters in between the quotes to the clipboard, and we'll use them here in a moment. We need to add our partition's UUID to our file system table, or fstab, or fstab, depending on the nerd you're talking to. To do this, we open fstab in a text editor called nano. So issue the command sudo space nano space /etc/fstab, or /etc/fstab. Move to a new line at the bottom and type PART UUID equals, and then paste in the UUID we previously copied from the block ID command. Tab /mnt/ssd tab ext4 tab defaults tab 0 space 0. Once you're sure your fstab is correct and looks like mine on the screen, of course substituting your name if it's any different, we exit nano with a Control X and then answer Y when asked to save our changes. Now, before we continue, reboot the Pi to make sure that our drive gets mounted on startup. Once we're logged back in, let's once again issue the df command and make sure our external drive is mounted at /mount/ssd. If your drive's listed, success. Step 2 is done. All right, if you've made it this far, the rest is cake. Cake. Without a doubt, getting the drive ready and performing how we want it to is the most time-consuming and cumbersome process in this installation. Thankfully, installing Docker and Docker Compose is much simpler. Just be aware that depending on whether you have a Raspberry Pi 3 or 4, there's one slight difference we'll need to take care of, but I'll point you to that change when we get there. Now, to get Home Assistant installed, you don't need to know Python, but we need to install it and its dependencies first. And then we can install Docker and Docker Compose, which again, you don't need to know necessarily, but we need to install them in order to install Home Assistant. If you follow the introductory tutorials on smarthomedumbUser.com, which you should because you're an awesome person, you've already used the apt package manager. We're going to use it here again to install Python and the necessary dependencies. So enter sudo space apt-get space install space -y space libffi-dev space libssl-dev. Enter. After entering this command, you'll see a whole bunch of output on the screen. So long as there aren't any errors or red text, we can ignore all of it. Next, to install Python 3, type sudo space apt-get space install space -y space python 3 space python 3 -pip. Again, you'll see a whole lot of output on the screen that can largely be ignored so long as there are not any errors. So next, we need to get the instructions for installing Docker and then execute them. We can do this with a program called curl and then send the output from curl directly to the shell by typing sudo space curl, C-U-R-L, space dash lowercase s, uppercase S, uppercase L, space https://get.docker.com, space pipe, space sh, enter. The pipe character is above the backslash character on your keyboard. This will take a few minutes to run, so it's a good time to take a break or a nap or grab some hustle juice if you're questioning your sanity right about now. Hustle juice is water in my case. Once that is completed, we add our Pi user to the Docker group so that it can run Docker commands. To do this, we use the command sudo space usermod or usermod space dash lowercase a uppercase g space docker space pi. Finally, we install Docker Compose with sudo space pip3 space install space docker-compose. Enter. And then we let that run. And that's it. Step 3 is complete. This is 3. The last thing to do is put Home Assistant in Docker, and thankfully the Home Assistant website gives us exactly what we need in order to do this. But first, we need to create a directory where our Home Assistant data will be stored. We do this with a sudo space mkdir space /mount/ssd /hass or has. To make the next steps easier, let's change directories or cd to our has folder. We do this with a cd space /mount/ssd/has. We're going to use nano again, but this time to write our Docker Compose file. So let's type sudo space nano space docker-compose.yml or YAML. YAML. It's just a fun word to say. YAML. 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 So the contents of the file being shown here on the screen are exactly as shown on the Home Assistant website with one or potentially two slight changes. First, under the volume section, you'll notice that we specify a config directory. This tells Docker where to store all of the persistent data for a container, which is Home Assistant in our case. It's this line which keeps the Home Assistant log from being written to the micro SD card and written to the SSD instead. Second, if you're running a Raspberry Pi 3, change the image name to say Raspberry Pi 3 rather than Raspberry Pi 4, intuitively enough. Once completed, press Ctrl X to exit and then Y and enter to save changes and return back to the command line. This is it. It's here. Time to start the install and start Home Assistant. Make this happen with sudo space docker-compose space up space -d and hit enter for the final time in this video. Give Docker a little bit of time to go out and download your image and install it, and to start it, and then just bask in the marvel of your accomplishment. Once everything has completed, you can open a web browser, point it to http colon slash slash the IP address of your Pi colon 8123, and all things having gone right, you should see the Home Assistant welcome screen being proudly displayed for your viewing pleasure. I understand this whole process is a lot to take in, especially if it's your first time with a Raspberry Pi or you're not familiar with Linux. But I can promise you that it only gets easier from here, from both a Linux and a Home Assistant perspective. Thank you so much for watching this video, and if you made it to this point in the video, give yourself a pat on the back and take a vacation, as I'm sure you've earned it. That's it for now. If you found this video useful, be sure to give it a thumbs up and consider subscribing to the channel for more smart home how-tos and how-to-nots. And be sure to stay up to date with all Smart Home Dumb User projects via Facebook, Twitter, Instagram, and of course, smarthomedumbUser.com. Until next time, keep the lights on and don't feed the bears. Get out of here. Go. Skedaddle. Scram.